So continuing on from the last video, we can use polar coordinates to find the position of the center of mass of the semicircle. So instead of taking strips of the semicircle, we can take little radial segments of semicircular set components of the semicircle. So here we have that the width or the radial thickness of the area element is just dr, and the arc length is given by r d theta, where r is the radial distance from the origin, which is the same coordinate system we used in the last video. So that means that total area is just the radial thickness, which is dr, times the arc length, r d theta, which we'll just simplify to r d theta dr. That means that our first moment is given by the double integral, so we have to integrate over the radius as well as the angle. So the radius goes from 0 to r. The angle, if we take the angle to be 0 here and goes around to 2 pi in a circle, it'll start at pi and go all the way around to 2 pi. So now we just find what y is in terms of theta and r. So if you're given theta, then by geometry, the y component is just r sine theta. So we have r sine theta, and we can bring out the sigma since it's a constant, and we have dA, which is just r d theta dr. So that simplifies to sigma equal 0 times r. So let's first integrate the theta component. So we've got the r squared here. So that's just a constant when you're integrating with respect to the theta component. And sine theta, the integral is negative cos theta. And we're evaluating that from pi to 2 pi. We still have the dr. So that leaves us with sigma integral from 0 to big R of r squared, and we have negative cosine of 2 pi is negative 1, and negative cosine of pi is just 1. So we've got negative 1 minus 1 is negative 2 dr. So now let's integrate the radial component. So the integral of r squared is just r cubed over 3, evaluated from 0 to big R. All of that is multiplied by negative 2 as well. So now we've got negative 2 sigma, which is just 2 times big M over pi big R squared. And that is all over 3. And we have, substitute in big R, we get big R cubed times negative 2, which is here. So that all simplifies down to negative 4 big M over 3 pi big R, which is what we got with Cartesian coordinates. So now our center of mass is just first moment divided by the total mass, big M, which is just negative 4 over 3 pi big R, which is the same answer we got using Cartesian coordinates.